Is that good, Damien? Is that ready to go for David?
Yeah. Okay, cool. Means us to introduce. Oh, what?
Yeah, so I'll have David go first.
Cool. So Damien, try to take a look.
All right, so welcome SF Network Automation Meetup. So we're going to have a quick lightning talk first. So David Barrasso of Fastly is going to talk about napalm and yay.
Before we start, who is familiar already with Yarn, OpenConfig, napalm? Okay, cool, some people. So, well, today I'm going to talk about some of the work I've been doing integrating napalm with OpenConfig. I'm going to skip this first slide. So, what is Yarn? Yarn is a data modeling language. There is even an RFC for that. It's super interesting. I recommend you to read it. What is OpenConfig? It's a vendor-neutral, model-driven network management designed by user. It's mostly a bunch of people with a lot of money trying to push vendors to build something that they can operate with. On the left-hand side here, you can see an example. This is the interfaces model of OpenConfig. On the right-hand side, you can see like a more human-readable way of seeing the interfaces model as defined by OpenConfig. And why should you care about OpenConfig? Well, OpenConfig defines an RPC service to interact with the devices. It also replaces somehow the CLI with data, and it's a common data model regardless of the vendor. So that's very interesting. So, well, that's cool. So when can I have it? Given how vendors move, I would say that we'll have it more or less when Half-Life 3 arrives as well. And so I've been working mostly on trying to bring OpenConfig into napalm to be able to start working with OpenConfig today, because it's nice to be able to operate with a common data model. So for those that are not familiar with napalm, napalm is a Python library that supports multiple network operating systems like Junos, iOS XE, iOS XR, EOS, NXOS, and many others. And the idea is that it provides a common API to operate the device. So you can say, oh, I want to deploy this configuration, or I want to get 3GP neighbors, or I want to rollback the last commit, or I want to get a diff of the configuration. It also normalizes data. The only problem is that we use our own models, which are fully defined sometimes. And it uses already available mechanisms. So if the device supports netconf, we will use netconf. If it supports a REST API, we will use that. If it doesn't support anything, we will just let me go to try to do some SSH scraping. The idea that it's something that works today. Like no other device that you're working with, you are able to use napalm and operate your network in the same way, like with the same sort of Python API. So, because I mentioned before that we were using our own data models, which are sometimes poorly defined, so we decided to start working on integrating OpenConfig. So instead of doing our own thing, just try to work with their models. The thing is that OpenConfig and napalm came to be more or less at the same time, so it was just a pure coincidence. So at that time we were doing our thing while they started at the same time. So this is an example of how to parse native configuration and turn it into OpenConfig. So this is just a YAML file describing how to extract data from a device. In this case, it's iOS and EOS, and build an OpenConfig object. This is the same for Junos. So by just having this YAML file, napalm is able to retrieve data from the device and build an OpenConfig object. And it can do the opposite as well. Like given an OpenConfig object, it's able to create native configuration. This is the example for iOS. And this is example for Junos. So just feeding the same data, the same OpenConfig model, you will just get native configuration regardless of iOS or Junos. You don't really have to care about that. And now I have some screenshots of some demo I prepared home. So this is how you would use Napalm to first connect to the device. In this case, it's EOS, but it's completely vendor agnostic, so it doesn't matter if it's Junos or iOS or something else. So first we just connect to the device. Now we can tell Napalm to parse the configuration and get the interfaces model. So here you can see like, give me the interfaces model, and then I can print it in a human readable format just for the sake of troubleshooting. You can see that I have a management interface, that it's of type Ethernet. I can see the MTU here. I can see that the description is empty. I can see that I have this subinterface here, 2.1, that has this description and so on and so forth. You can see also the port channel is of type lag, and the rest like the loopback interface. So I can as well start manipulating the configuration just by manipulating the OpenConfig object. So I can say like, okay, first off, I want to create a candidate config. Now I want to here change the description of the management interface. And I want to remove the description of the 4-channel one. I want also to shut down this subinterface here. And I want to create a new loopback interface. The idea is that you start manipulating the object. You don't really think of the vendor syntax. It's just like, oh, I want to create this loopback interface. And you're just manipulating it by using the OpenConfig model. And now that I have the object, I can say, okay, now translate the model to native config. And I would get just like, okay, so the object that we had before maps to this native config. But more interestingly, I can even merge the object that I manipulated into the running config and get the instruction that I have to execute to actually go from the candidate to the running. So now I see like, okay, the first thing we did was remove the loopback one. And I also changed the description of the management interface and removed that subinterface over there. And this is just mapping the candidate configuration into the running configuration. And if I load that into the device by just using the other Napalm functions that we have, I can then just load the config here, and I can tell Napalm to give me a native diff. This diff is actually given by EOS to Napalm, and I can see that it's actually changing what I changed on the OpenConfig object, which is just removing this description, is shutting down this port, removing the loopback one, creating a loopback 0, and so on. And then finally, I can just commit the configuration. I can load it again, and I can print the diff again to prove that the configuration went through. As you can see, because now the diff that I got before now is empty. And this is pretty much it. If someone has questions, I'll happy to try to answer them.
So how do you see this? So you're going to build like config objects that are sort of abstract and generic in Yang, and then it'll get translated into whatever platform you want it to be on and be able to push it. Like, how do you sort of see like a usage model of this a few years down the road?
So that's not built yet, but the idea is that you will feed, instead of manipulating the objects like this, I mean, you can do this if you want, like you're building your own, I don't know, like provisioning portal. I mean, you could do this. But the idea is that if you're using something like Ansible or so, you would be providing, instead of manipulating the config like this, you would just provide a dictionary or a JSON or a YAML or something, and then that would just map into the values automatically. That's not built yet, but that's one of the things that I was planning on building. So you just feed the dictionary and the object gets manipulated. Like
So
that.
you would have all these key value pairs in
Correct.
some JSON or Python directly.
Yeah.
That would get
Yeah.
translated directly into the Yang model, and then you could.
Yeah, that at the end it will look exactly as just printing the object in a dictionary format, which I didn't show it, but it supports it as well. So you can just get the object in a dictionary format, which could be used later on to feed it into a different system or something.
Do you use it for
Well, this is just a mean to interact with the device. How you use it, it's up to you. Like you could use it with Salt to orchestrate something, you could use it with Ansible to deploy config. If you're using Open Daylight, you might use this as southbound interface. So this is just a library, you can use it however you want.
How about the testing environment? What kind of testing you're harnessing on top of this?
Testing?
You mentioned a long list of operating systems. Are you aggressively testing it?
Yes.
Whatever changes?
So
Test case.
we have a very complex testing framework. So the testing framework is provided by Napalm, and every time that there is new code, mocking data for the particular vendor has to be provided. And so every time that there is a push on GitHub, there's a Travis job that tests everything. And it tests both that the code works and that the code works exactly in the same way regardless of the vendor.
Yeah, related to the question she asked, is there any orchestration layer tools using your stuff as a southbound interface? Because that's the pain point for the operation team, right? They want to interact with the router and switches, but then if something happens, you have to see it and then react again using southbound interface. So, something sitting on top of you, you're aware of?
Well, I mean,
Any vendor were using it?
I didn't want to solve that problem because there are a lot of good tools doing that. I just wanted to give the means to build whatever you wanted to build.
Right.
I know some people using Salt, I know other people using Ansible. I'm pretty sure that there's people writing their own stuff. So, that's just like an application for like something on top of it. Like Napalm is just giving you the southbound interface.
Thanks.
Thank you, David.
Thank you.
Yeah, so David does an amazing amount of work on Napalm, so he's doing a tremendous amount of work, and the contributions that he's making, that him and a set of other people are making available, they put a lot of, and me included, we put a lot of effort into that, so I think there's a lot of value in it, and I think it's really cool. Okay, so I want to do a couple of thank yous. So first of all, I want to thank WeWork. So they basically, I work here, so I'm using co-working space here, but they were nice enough to let us use this. They didn't charge me anything. They were very nice about it. They let me do it on fairly short order, so that was very, very helpful for them to do that. And then I also want to thank Apstra. Apstra donated the food for tonight. So I want to thank them for doing that. They paid for all that, and then I want to let someone from Apstra just talk a little bit about what they're doing, and then Damien's going to come up and give the main presentation.
All right. Thank you, everybody. So I'm Jonathan Garzon. I'm the product manager at Apstra, and we do data center network automation. Apstra, so we're a startup based in Menlo Park. We're building a software that we call a distributed operating system that runs on top of your infrastructure, hardware, and network operating system, and provide a full network lifecycle automation of your data center, which means that we help network engineers with the design phase, the deployment phase, and the operation phase of their data center network. We're unique in the fact that we are managing both the configuration management aspect as well as the network states of the network, and we are making sure that they're constantly in sync, meaning that what you intend to configure is actually behaving in the network the way you expect it to behave. And so we keep those things in sync, and we derive both network configuration and network states from what we call the user intent, which is an abstracted specification, declarative specification of what the network should be doing, describing what the network should be doing and not how the network should be doing it. And we're actually in charge of making sure that we compose the services so that it match the actual user intent. So we do that, we call that closed loop, the fact that we're making the configuration match the network state at all times. We also describe ourselves as intent-driven, the idea that we describe what to do and not how to do it. And we're also vendor agnostic, or we like to say vendor inclusive, meaning that nothing of what I described actually depends on the actual hardware or vendor that you select. You completely abstract the actual network device, and you don't have to you don't have to change your operating model if you switch from vendor A to vendor B. Your service model and operating models are completely decoupled from the actual infrastructure. So why this is important? The fact is that only hyperscale company, web company, have been basically able to build such system today. These are the Facebook, the Google, the Amazon. They've hired tens, if not hundreds, of engineers and worked on years, over years, to actually build such complex system. And we're actually providing that as a commercial software. So providing any company with the same level of operational efficiency, business agility, and last but not least, the fact that we are vendor inclusive, agnostic, means that you can select the vendor you want to build your next pod. And that means that you can select the vendor based on your actual use case. If you want low latency, you may want to select one use case. If you want, if price is the most important factor for you, you may select another one. So you have the choice without changing any of your operating models and service model. I'll be around, and I'm happy to talk to you and tell you more about what we do. Something else I wanted to mention is that we are also really pushing, really wanting to work with the open source community, and we have some actual projects that we have already pushed, so that you can find at community.abstract.com. The first project we open source is what we call Universal Zero Touch Provisioning Server. So one of the first issue we actually came up with is how to install our own agents on devices in a multi-vendor way, and we didn't find any easy way to do that across vendors. I mean, Cisco, Arista, Cumulus, and so on. And so we solved the problem for ourselves, and we contributed back this code to the community. This is something that our customer enablement team did. So Damien is actually part of it. Jeremy Schulman is heading that team. And I want to say that we're happy to come back to this meetup to tell you more about our universal ZTP and exchange idea on the subject. With that, I welcome Damien for the real meetup.
Thanks. So I'm Damien. I'm going to talk tonight about Ravello and how to build virtual topology on the cloud. And so, quick about the agenda. How many of you know about Ravello? So like, okay, 25% of the room, so that's good. So I'm going to do a quick introduction to what they're doing. I think it's important. Then I will show how you can easily build topology in Ravello using tools like Ansible. So that will involve some project that I built. And I hope we'll have time. I'd like to introduce the idea of using Ravello as part of building a continuous integration pipeline. I think everybody talk about automating the network, we'll talk about writing codes. We don't talk enough about testing those codes, testing those tools. And I think it's complicated, and with Ravello we have a great solution. So just a bit about me. I've been doing data center networks for 10 years, network automation for 5 years. Very recently I was still with Juniper, doing a lot of Ansible and a lot of things for there, and recently I joined Astra, part of the customer enablement team. Quick disclaimer, I have absolutely no relation whatsoever with Ravello, neither with Ansible. So I'm not selling it, just really I believe right now those solutions are really solving something. It's a very early project. So actually very few people apart from me are using it. Everything is open source, and I'm going to show you, I have the link at the end of the presentation. So I'd love to get feedback. There's many things that can be changed. I'm sharing that to improve. So I started everything at Juniper, so it's actually, a lot of it is still open source under Juniper GitHub account. But I'm actually planning on still contributing to it. I'm probably still the main maintainer. We have plans at Abstract to use that because that solves some of our problems as well. So, and we'd love to get more people involved. So, quick introduction to Ravello. So Ravello in a nutshell, I will give you a demo, but basically it's a solution that lets you build a virtual topology and they run on top of AWS, Google Compute Engine, or Ravello Cloud. So they have built their own abstraction layer that runs on top of those three platforms. Those three platforms are completely invisible. You don't have to create an account, but they will run on those solutions. And what's really interesting is they don't have any requirements like AWS. You can run any type of VMs. You just take any ODA, ING, anything that you get, and you can upload it, and you can start building a topology. All the billing is done by the hour. So running one VM for 1 hour, it's like 10 cents. And you will pay on this basis. And a few months ago, they've been acquired by Oracle. But technically, they keep saying that it's not going to change anything. It's just Oracle wants to run this cloud business, so it's actually an important part of it. I tried to give you an idea of the pro and the cons, the way I see it on Ravello. So the pros are, it works with all the VMs, and it's very important because the VMs we get from the network vendors, they don't work in AWS by default. They don't have password, they don't have SSH key, they don't have all that. So you get an ODA, you get an ING. All of those will usually work on that. Any type of topology, there's no restrictions. Layer 1, layer 2, layer 3, you can do any of that, support LRDP, LSCP, you can do all of that between your VMs, things you cannot do on other clouds. They have a very solid REST API, even though it's actually not the best, but it's you can technically do everything through the REST APIs, assuming you can work around that. You can give public IP to all your VMs, so it's very nice. I was like very often, like for example, starting my topology on the cloud, and I was running everything from my laptop. The same way it was actually my physical lab, and all my VMs had actually a public IP, and I was able to SSH and do everything directly to it. They have some, and I'm going to show you that. That's probably the thing that people don't know. They have some very interesting features that are the notion of blueprint and token that really make it very, very good for topology. So I'm going to show you that. And technically, it is unlimited capacity. So my biggest, I tried the top, I had 700 VMs running on it. At the same time, I was running a training with a few hundreds of people, and that was working great. And at the end, it cost me like a couple of thousand. Actually, we had the training for 3 days, and we were running the VMs for several hours for 3 days, and at the end, it was only a few thousand, which is really cheap for what it is. And all the tools that I built, actually initially built them for managing this training. So yeah, it's very powerful. The cons are, because they run on top of AWS and all, they actually have their own virtualization layer. So we're actually 2 layers of hypervisor already. And I know, for example, if you want to run a VM that has its own hypervisor, that will be super slow. And even the first level that you can run, it will run, but it might be not as performant as you have. So usually you have to over-provision the CPU and the memory. The biggest part, which is terrible with Ravello, is the way they have designed their network. The way they define how to build a network between your VM totally sucks. It is absolutely terrible. There is no other way to do that. It is absolutely terrible. So the goal of this project I'm going to present is try to solve that, because it was so terrible that I just couldn't do that. So their API required, like, it's kind of restrictive in the way that you cannot do just an incremental change. You actually have to change everything. So it creates some complexity on the client side, where you need to manage and understand what you want to do and see the global context before doing stuff. And yeah, I mean, don't see that as a replacement for your lab. It's a cloud-based solution. So if you run 24 hours a day, it's not going to be interesting because it's going to be very expensive. It is very interesting if you run it like few hours here and there, but and then that becomes super interesting.
Do you know if you can run it on an existing cloud account, like if you have a Google Cloud Engine or AWS account? Can you tie it to like your...
No, actually it's the fact that running on AWS is completely transparent. You need to create a Ravello account, give your credit card, and they will deploy on all the clouds for you. It's absolutely transparent. You don't see it. You don't even need to have a AWS accounts or anything. A few of the use cases. I think training is a big one. Very easy to spot up dedicated labs for every student. They have this delegation and token system, and we're going to talk about. On-demand labs, really reproducing large topology, like if you want to simulate change in your networks, create a very large topology for a few hours, that's very cheap if you not let it run for very long times. And the things where I really believe there is a huge value is all the CIs. Because if you know a little bit of this notion of continuous integrations require some large amount of resources for a short period of time, and it's totally unpredictable. So it means technically you need to have over-provision a lot of resource that you will use only a few hours. So for that, it's absolutely perfect to use those solutions, and it's really good for the CI part. So just to give you a quick, if you go to ravellosystem.com, you will actually you'll have to create an account. Let me see if I can make that a little bit bigger. So basically the way it starts is you need to create your the VM. So they have what they name the VMs library, and you can easily upload your own VM. There is an import button. You just give your VA, give your VMDK. You will upload the VM, and you will have the ability to choose how much CPU, how much memory you want to give your VM, how many interfaces the VMs will have. You can define those parameters. And based on those VMs, you will be able to create an application. So,
hey Damien, so sometimes like I've used with KVM, I've had real troubles getting some vendor VMs working. How difficult, easy was it for you to get the VM, particularly like what settings you feed in? How easy, difficult was it for you to get the VMs running?
It is pretty easy. You need to know like the type of the network interface, especially for networks like some will require the VirtIO or stuff, so you need to know that. You need to know just usually CPU and memory. Apart from that, that's actually pretty easy.
Were you pretty much using Juniper virtual devices, or did you try it with other?
I know Arista is using it, Cumulus is using it. At Juniper, I was able to run VMX and VQFX. We cannot run VSRX today because of this nested virtualization. But yeah, I know more and more. I think Cisco, we have some Cisco as well running there. So it actually works pretty good.
I've struggled with at least running Arista VUS and Cumulus the CDX on Ravello.
So now, if you want to build a topology, you just drag and drop through the end. So here I have like a VQFX, and I will take, for example, what do I have, like a Cumulus box. So you will drop them, and that's where I was telling you. So you can name them, you can do things with them. The part that is really bad is the network. Technically, all those interfaces, if you look here, they have a lot of those VMs. They have a lot of network interface. And by default, they all go to the same place. Now, if I want to tie the third interface of my Cumulus box to the third interface on my Juniper box, the way I have to do that is I actually have to go on the network. I need to go down to the third interface. So it might be hard to see, but actually you see there's a number 3, for example, here. And they have this crazy idea that to connect a physical link, you actually have to put some IP addresses. So they actually use IP addresses to define who's connected to who, but the IP address don't have any meaning for the real network device. It doesn't mean anything. You can have any traffic running. It's just a way to say if they are part of the same network subnet, they will connect to each other. So if I say 10.10.0.1, and I say it's a /16 some here, I need to go on the other side and pick any interface, and I need to make sure I don't use the same IP address, and I need to have the same network, and then automatically I put 10, 10, and 10. So if I do that now, I have those two interfaces that are connected to the same layer 2 domain, which means the same bridge. Which, if you have to do one, it's okay. If you have to do like an IP fabric with links everywhere, you will shoot yourself. And what's terrible is if you want to upgrade this box, you actually have to delete it and import a new VMs and drop a new one. And because the network configuration is tied to the box itself, the VM, you have to restart everything. So that's really the problem I was trying to solve. So now what's really cool is so you can expose I can say, okay, these VMs I will actually expose, for example, SSH, and I will do that on the first interface on port 22, and I will do the same on Juniper, so you can define all those services. And now you just have to deploy. It shows, you can select if you want to run on a specific data center, specific cloud. Usually you decide how long you want it to run. So here I will say 1 hour. And you just publish, and then the application will actually boot up, and you will have, because I define public service exposed, I will actually have, here it might be difficult to see, but I will get dedicated DNS name to reach my VM. They will get, in a few minutes, they will have IP addresses. I will be able to SSH to them and everything. So what's really interesting as well is they have this notion of token. So I can create a token to delegate access to this topology to somebody. And for example, if I say, I want to give access to Kirk to this topology for 2 days, I will create a token and I will say, okay, Kirk can see the topology, can execute the topology, and I will say this token expires on Thursday. And I will create this token. And what it will give me is, I will actually have a dedicated interface. So I'm going to open this one on a private Windows just to show you it's really, Kirk doesn't even need to build it to create an account. If I give it to Kirk, he will be able to go there, and he will see the two VMs, and he will see the states, he will be able to access the console, he will see so for training it's just perfect. Like you can spin up 10 topology and you give those links to the students, and everybody gets its own management interface, no needs to create an account. I run that a few times on training. It's with hundreds of people, that works like beautiful. It's just perfect. There's no better way to do that. And he can start, he can stop, he can access the console if you messed up the configuration. Everything is manageable. Technically, there's even a link where he could have access to the real management interface, the same as me, just for this application. But usually you don't even need to do that because this one requires kind of some knowledge of how the interface works. The first one is actually purpose-built for students and people who delegate the access. It's very important, those tokens I think are very important because that's actually what I'm using for building the CI pipeline. Because when you build CI on GitHub, so for example, that's what I'm going to try to explain at the end. Last part is if David tomorrow wants to build proper tests using real network device on an open source project that is on GitHub, today it doesn't have, there's no way to actually connect to physical device, real device to test that the Arista API is actually working properly or all those stuff. So with Ravello you can do that, and with those tokens there's a way to delegate some of the control without exposing all your credentials and being really safe on who can do what on those networks and all those kind of stuff. So it's great for training and it's great for CI. Does that make sense? Any questions on Ravello?
Is it possible to connect it to an existing network through like a tunnel or something?
Yeah, actually you will have to, I don't think they provide that, but I know some of my colleagues actually have the VMX running, and they were running an IPsec their internal lab with the
To like
yeah.
like the hardware running in
And
the
they-
lab,
yeah.
not to like.
Actually, for our labs, we were having like a virtual device that was connecting to a physical device in our lab, doing like that, running that. Yeah.
But it has to go over the internet, correct?
It has to go over the internet. Yeah.
Alright. Gotcha.
So that's for quick intro, 5 minutes and a bit more on Ravello. Yeah, I mean, I think it's a very, very powerful. One thing I get all the time, because I was pushing a lot for a virtual device when I was at Juniper, and everybody was like, oh, why not using just Amazon? We have AWS, AWS is so great, everybody's using it. But the truth is, you cannot use AWS to build virtual topology, to build a lab. It is not meant to build a lab, it's meant to run VMs. You cannot do layer 1, you cannot do layer 2, I mean you cannot do LLTP, you cannot do LSCP. It's not meant for network topology. It's meant for applications that run on layer 3. And so there's many things they don't have. They don't have the notion of topology, they don't have, they have requirements, like a VM to run on AWS actually needs to support cloud init, and so most of the devices that you get from your vendors don't do that. And for many reasons, it just doesn't work. So get that out of your head. AWS is not a solution to build virtual lab, period. It's an application to run VMs, an application on the cloud. It is not something to replace a lab. And that's why Ravello had to build a very complex system on top of AWS for that. So, because the tool is very interesting, but very complicated to build those applications, very manual process. If you need to change something, it's complicated. And I told you, like, all the network topology sucks, and it's tied to one VM. So when we build network topology, every week there is a new versions that come out, and the new versions come with a new VM or a new image, and you mean you will have to rewrite your topology, and basically that's not going to be something fun. So the idea was first abstract how you define a topology. So there's part of that. And then I automated the creation of those topologies using Ansible. Because, I mean, I use Ansible because of that's actually the tool that I was mainly using at Juniper to configure the device. So I actually have some project where in the same Ansible project I'm able to generate the topology and configure the device using the same inventory, using the same thing. So it was very powerful. And I mean, it's very lightweight, it doesn't require agents, it can run on any laptop, so that works pretty good. How many of you are not familiar with Ansible? Okay, only one. Wow, that's impressive. Perfect, because I'm not planning on explaining what is Ansible and how it works, so that was not part of today's agenda. So I created this project, and right now it's posted on github.com/juniper/Ravello-Ansible, and it actually contains some Ansible roles, and there's few of them, and that's the part where I really would love to get feedback, because even myself sometimes I'm trying to understand why I put so many roles and why I name them, but basically what they let you do is you can completely create a new application. That's what I'm going to show. You can also, from what we name a blueprint, we haven't talked about that, but it's basically a reference architecture. You can create many applications and automate the generation of the token and gathering the IP addresses and all that. So that's what you will use for training, for example. And you can stop the VM, start the VM, collect the IPs, and so there's all of that on GitHub. Everything is public. I also have a Docker container that actually has Ansible and all those roles pre-installed. So that if you want to try, you don't even have to install on your laptop. And again, it's really alpha mode. There's some documentation. It can certainly be improved. I'm looking for the first users. So as an example, let's try to build this topology, very simple, spine and leaf with 2 spines to leaf. The way I address the problem is I assign a unique ID to every physical link And the way I do that is actually I draw exactly like that, the topology, and then I just very quickly put the numbers on every physical link, and you will understand later how it works. And you also need, when you build VMs, you need to understand, it's not represented here, but you need to assign ID to the interfaces. Because when you build the virtual VMs, I don't know if you're familiar with that, but the order in which you create the interface will determine their name. Like for example, if you create a Juniper device, the first interface is the management, the second interface is reserved to connect to the packet forwarding engine, the third interface is reserved, and the fourth interface will actually be the first one you will use to connect devices together. So there is an order to respect. And every virtual device has its own order, and there is a predictive way where you know, like, the fourth interface will be XC000, or the fifth interface will be another name. Every vendor and every network device, virtual network device, has a specific one. So you need to know which number of interface you want to connect to device and all that. And once you have that, the way I say the simplest, the only things you need to define in this model is actually those two files. So there's one file, which is an Ansible inventory file, where you actually list your device in an Ansible way. And you can create groups, and you can create all of it. The only thing that is really mandatory is that every device needs to have a unique value that is ID, variable named ID that it needs to be unique. You need to define a variable that is named Ravello app name, which will be the name of your applications when you create it. And you can have different one technically. You know, here I'm putting that the same for everybody, but you will use the name of the image the way it is on Ravello. You know, when I was looking at Ravello and I was in my library of images, of VMs, you just pick the same name, whatever is this name, and you put it here, and that will define what is the base image that will be used to create this VM. That will spin up 5VM. And then that's the way you define how you actually connect them, and it's, I think it's very simple. The idea is you need to create that under Ravello underscore topology, and for each VMs, and it has to be the same name as the one you have used here, you will just create a list, and that will be the interface the way you create them, like first one, second one, so it's very predictable. And if you want the VMs to have a DHCP address, there is the keywords, which is DHCP public, and you can define what you want to expose outside. And if you want just to create internal network, you just assign a unique ID. And two interfaces that have the same unique ID will be connected together. So here, the last interface of my spine 1 has the ID 15, and the fourth interface of this one has the ID 15. This means they will both be connected together. So it's as simple as that. And actually, it is not extremely readable, but I was able to build like 10, 15 nodes topology pretty easily. You just put it down, you draw all the links, you give an ID, you keep count of which interface, and then you just build this file, which is at the end pretty easy.
So the order doesn't matter here, right?
The order matters.
Matters.
The order matters for the VM itself. Because the VM, every vendor will tell you first interface management, second interface. So here at Juniper, I know that the second interface and the thirds are reserved, and if I want to make connections, I need to use so actually my 93 and 83, those are connected nowhere. I just connected those interfaces to nobody.
So in this second file, you don't have the vendor information. So if you're assuming that's Juniper, down the road, if you're changing it to someone else.
Yeah, down the road, if you change the vendor, you actually need to change this image.
As well.
You need to change that as well. That's absolutely.
That's kind of coupled together.
There is actually the way I was doing it is on my inventory. I was also specifying the name of this file. So it's mean if you have actually different inventory, they will do that. But yeah. So just with that, I just put that on for the. That will let you create your topology. So I'm just gonna give you a quick demo.
And
So
this is all connecting to Ravello through their REST API? Or
everything through the REST API.
Okay.
So actually, this is my real inventory file. So technically here I also have like, I'm gonna use Juniper. That's the one I'm most familiar with, but technically it will be work with any of that. And also the Juniper, actually, it's, anybody can download it. I put the link. So if you want to try, anybody can actually access this VM pretty easily and try on your own. One thing is there's two other variables that you need to define. I don't have it here. It's the login and password for your Ravello account. Yes?
So how easy was it, did you have to write an Ansible module for this? How easy was it to do the Ravello integration?
So actually I worked on that as an intern. We did a few backend trials. We had to write one module because the thing is Ansible, we wanted the user to manage names and not IDs. Because Ravello, you know, they manage everything with a unique ID, which is a very long number. But we wanted the user to manage names, and we had to write a module that actually converts names into ID. This one we couldn't do it with just Ansible. Everything else, it's actually just Ansible playbooks that are packaged in roles. That works.
In that Ansible module, is that in that same repository?
Yeah, everything is the same.
Okay,
the
cool.
same. I was thinking at some point maybe some of that should be turned into modules to bring the independency and more some of the good stuff that Ansible has. That's exactly the kind of feedback I'd like to get. Myself, I'm not sure. That will require a bit more work. There's pro and cons in both. So yeah, you need login and password. For me, I define them somewhere else in an Ansible variable file. And I just have my file exactly the same I show you, except here I have like my 5 devices. And I define and just expose SSH and SCMP. So in this repo, I'm actually using the Docker container, and I make a make file to simplify things. So technically, if you run things, you just have to call like, so actually let me, because there is a role that creates the application, technically you just need to have a pretty empty playbook that calls the roles and that reference the file that has all the information about the topology. And if you call that, it will create the application. So if I run it, all I have to do is make create, and it will actually. So here I run Ansible in serial mode. It means there is no multiprocessing. It's mainly because the Ravello API doesn't like when 5 requests come to change and make modification on the same application at the same time. So the way I did it is every VM is a device that's part of the inventory. So you can actually use the limit. If you have a very big inventory files and you want just to create like pod 1, you could say limit pod 1 if you have created this group, and it will just create pod 1. If you really have something very complicated and you want to, you get a lot of the mechanism that Ansible has. You get all the variables. So here it actually has created all my device, and if I go on Ravello now, you see I have my IP fabric Junos, I have my 5 devices, and now it really looks very small, but actually like all the interfaces are mapped to their individual, so there's individual layer 2 domain for all the point-to-point connections, and they are all connected to each other. And if so then there's a keyword named deploy that will actually take the application and start the VMs. So just download everything and start all the VMs on Ravello. So now you see that the VMs are actually booting up. So that's what those things means. And in a few minutes, we will actually be able to collect the IP addresses. And what I'm doing is I have a role, a playbook that actually downloads the IP address, and I publish the variables locally on my project. So it means after that, I'm able to run any playbooks, and it looks like my devices are actually on my lab or anywhere. And I can just access them, I can do whatever I want with them. I don't have any knowledge that it's actually running on the cloud after that. So I try to keep this project simple, so I don't have configuration, I just have a simple playbooks that I think run show version that I can, once those have finished to boot up, I can show you, but apart from that, I don't have, I try to keep it simple. I'll send you the link as well to this one.
So the config, and sorry if I missed this, can you have it boot up with the config you want, or do you have to push that through?
It's up to you. So, I mean, the way you build VMs on Ravello, you can have a VM that has nothing. You can have a VM that boot ups with DHCP. You can have a VM that has a full configuration. It's completely up to you. The thing is, you can upload a VM that has nothing. You can make the change manually, and you can take a snapshot and create a new image, and then you will be able to use this new image. So the way I do it, at least for Juniper, is all the VMs come up with DHCP and netconf enable. DHCP on the management interface, but that's pretty much it. So it's a very generic based image. And then all I need is just connect to that and push my things into it.
So then when you update the software version on the virtual router, you have to go and create a new template image with the...
You need to upload the new, for example, you get an OVA from the vendors, you upload the vendors, you create a new VM inside your library, and you just have to go here and change the name of your the VM. This is really the name that you have in your library. So whatever you put on the library, if you create a new one, you can reuse that. It just has to match. That's the way it finds the VMs, and you can reuse that. So if you have automated everything, you can spin up a complete topology with this new image in very, very easily. And the idea will be automate as part of the same project, automate the remaining part of the setup. Building the topology is one thing, but usually you have to configure the device and configure the application, but everything can technically be done from this place. Any question? I'm not sure how much time we have. So, I'll move on. If there is no more question, I'll move on to the next part. So I was telling you, yeah, I'm not sure if we should create roles, modules very early. Please provide feedback and don't throw stone at me. So yeah, the one thing I really like, and I think it has so much potential, and I am very frustrated that we don't do enough testing on the network, is with Ravello we have a huge opportunity to do part of a CI pipeline. So the real idea is we write all those scripts, Python, we write those Ansible, technically even Ansible project that generate configuration. We need to test the configuration that we actually generate. We need to test either if it's a code, if it's, there's so many things, all the things we create dynamically for networks, we need to test them. And today, it's very complicated. Even if you're running that internally, you might have your physical lab, but technically maintaining a physical lab in the right state is complicated. And one thing people often forget is as we start to write scripts, we want, for example, to test them on iOS version 13 and 14 and 15, because you can make sure that something will go wrong. So how do you test on 3 versions of your operating system at the same time? It's very complicated if you use physical lab. And using virtual lab, it's also very complicated because you have to over-provision everything, and we are actually lacking a proper in-house solution that has the right API that will, the server guys are using Vagrant, but at some point Vagrant, it also has some limitations in how many devices and how big of the topology you can build. So we're really missing something. And that was for on-premise. When we are talking open source projects or things we are building online, like Napalm, it's even worse because how do you access real physical device from internet? So the idea was now that we can automate the creation of those topology in Ravello, let's do that as part of the CI process. And how many of you are familiar with Travis? So very few hands, but I have 3 hands. You should learn them. It's so important. Sitting on an automation meetup and actually Kirk, we should, and I'll be happy to come back and explain it to anybody, and I'm not the only one, but we should have like sessions dedicated on doing testing for network and not just for network. So I tried to explain that. The idea is you will have your project on GitHub or any repo, and there's those tools. So Travis is one of them, Jenkins is very popular in enterprise, there's GitLab CIs. What they can do is every time you do a commit, they will actually download your repo, and they will follow a script that you have defined, and they will run, basically it's like having a VM that is spun up every time you do a commit, and you can do whatever you want with this VM. And usually people run tests inside this VM, but you can do whatever you want. So the idea is, have your project and all the scripts and Ansible playbooks here running on GitLab, and every time there is a commit, Travis will download everything, and you can actually run Docker in Travis, and you can use Travis to create the topology on Ravello. Exactly what I show you, you can do that every time there is a commit, build the topology, download the new IP addresses, like wait 5 minutes for the VMs to boot up, and then from Travis, you will be able to run your test, and you will be able to connect through the IP to the real virtual device. And what's really interesting is Travis has this notion of you can define variables, and you can define, so you can say for every test, every time there is a commit, I want to actually run 3 tests, not 1, 3 jobs. And meaning you will actually spawn up 3 VMs, and one will be for versions 1.1, version 1.2, version 1.3 of your devices, for example. And because it's Ravello, because it's the cloud, you can actually spin up for 1 hour 3 different versions of your applications and run that and run your test and report that and really validates that everything is working good. So I actually it's working, but the process is fairly, like it's 10 minutes long, like you need to boot up. So I took some screenshots, but what I did is I pre-created, yeah.
So, in trying to tie this into an open source project, like how do you, is there a way to like delegate? Like if you have the issue of you need an account that's paying money, how do you like delegate it?
Yes,
to, like, say that I have a fixed amount of money that can be used?
Someone has to pay for the VM that runs. And today, the owner of the open source project will have to do that. But the thing is, think of it like if you run, even if you have hundreds of commits a month, which is not that many, it will cost maybe $50 a month. Or the amount of money you will get is actually very, very small. I understand for open source it's still...
No, I wasn't worried about the money as far as like, is there a way to properly delegate it to say, okay, any commit coming in, here's the account it's going to be used and how to constrain.
So the way I did the constraint, there's actually, that was one of the big problems. When you do outside, you don't want to expose your whole Ravello stuff. So the way I did it is actually, I create a blueprint. So you take an application, turn it into a in Ravello blueprint. And on this blueprint, I assign some token. You know the token we are talking about? And the token, the only things it can do is start the application and stop it. So it cannot change it, it cannot create a new VM. So technically this blueprint has actually, these tokens have very limited capabilities. And personally I believe it is enough to expose that outside. And you can also, in Ravello, you can do some restrictions and say, for example, only the IP address coming from this range can access my VM. So you could, I was trying to do that this weekend, but you could try to get the IP addresses from Travis and say, okay, I know that something running on Travis will come with those IP addresses, and you will restrict that only Travis can access your VM. So really, there is no point for anybody to use your token. The only thing they can do is spawn up your topology in your network device, they cannot even access them. They cannot, you know, I believe it's fairly restricted. Some people from security will throw things at me, but I believe for some people that will be enough. So that's exactly what I did actually. I built two applications, two blueprints, and I built one with the version 1.1 of my application. So actually I'm at Abstract right now, I'm developing Ansible module to control Abstract, our own product, the EOS. And I need to test that. And the modules are open source, everything is online. And so I created two applications, and we're in different versions of our own software. And I put them here, and I created individual token for them. And I just kept track here of what is the blueprint and the token ID for version 1.1, and what is the blueprint and the token for version 1.0. And then I have my inventory file. I hope it's big enough. I can actually go here. So, sorry for switching side. So this is actually my, I hope it's a bit bigger. So the things you have to define here is the name of the application, the name that you will have on Ravello, how will you name the application, and one of the tricks is you actually want the name to be very dynamic because you cannot have duplicate names. So you need to pick up the commit ID from Travis and the Git commit ID and the Travis job ID to make sure that all those names are completely unique. And then you will need to provide the CI token and the blueprint ID. And based on that, I have written a playbook that will create everything. So I name it init CI. And this one is just a classic Ansible playbook, but it will actually go and it will control the Ravello API just with the token. So you don't need to provide login and password. And it will create your application, do everything, set up. So the way I did it is automatically the application will stop after 50 minutes. So you're sure to not pay for more than 1 hour. Wait for the application to boot up. And at the end, you will just download the IP address of those VMs, and you will populate the files locally with those information so that the next task that you run knows how to access those VMs. And that actually works great. So I have it set up actually for the Abstract account. And for example, that's how the result of a job looks like. So let me show you the Travis file first. So Travis is actually, you hook your repo with Travis and you define what Travis will do in this file. And here what I say is I want to use Docker, and I define here that I want to run 2 tests with 2 different versions, 1.1 and 1.0. And you can run some installation. So here I actually build my Docker images first. And I download one that is online. That's pretty much all I'm doing. And then I have 2 actions. So this one, which is a bit long, but basically what it does, it starts the topology. We setting up everything and starting the topology. And this one will actually run my test. We start up in parallel. And it created 2 applications at the same time on Ravello. And those 2 applications were running in parallel. And I can see all the logs, and I can follow exactly what happened. So this is the creation of the topology, and then those are actually all my tests that I'm running. So it's just a simple example of this one, but the idea is that we really have a powerful solution for doing tests on real devices. Question? Pretty much.
Do you also automate filters, like firewall filters?
Firewall filter on Ravello or on the physical device?
On physical device?
Yeah, I mean, for most network vendors, they provide solutions to automate that through Ansible as well. Yeah, absolutely. You can do it. There's no more question. I'm done. I think. Thanks for. I will share the presentation, and I put some links with the. I have some sample project examples and how to get the VQFX and how to get all those kind of things. Again, I'd love to hear feedback very early, and I know we're planning already on using that at Abstract because we have for us it's actually we use Ravello extensively. We use that for demo. We build like very large topology to explain how the products. We have training, we have many things, and that's going to save us a lot of time. Thanks for your time.
So that's pretty much it. I mean, we're going to hang around. I'll hang around here for a while, so feel free to mingle for a little bit. And if there's any food left, feel free to have that. But thanks, everybody.
Thank you.
Thanks.